In this video, we'll take a look at more advanced C# syntax and language features. Not all of it's specific to Unity, but where it is, I'll make a mention of it. So this builds on what we learned in the last video, but this will be some more advanced things. So first we'll take a look at generics, then talk about delegates and other ways to communicate, something like event dispatching from other languages you're able to do in a variety of ways, something like anonymous functions in other languages you're able to do in a variety of ways. Then we'll take a look at threads, which in this case is really about coroutines, extension methods, operator overloading and overloading in general, attributes, and preprocessor directives. So let's get started. For each of these, like in the past, there's a folder specific for the project and subject matter. There's a scene to it. Inside the scene, there's a manager's game object that has one main entry point to the code. Just like the scene, there's a similarly named C# class. And then if that class needs any supporting scripts, they'd go here. And all of that is separate for each of these. They all work in isolation. So let's get started with first generics. So I'll give it a run. We see we've got a native generic, meaning something that Unity provides for us, a custom generic, meaning something that we authored ourselves, and then a custom generic with a constraint, which is called a where. And let's take a look at each of those. So I'm going to open up within MonoDevelop that main class file. Alright, now I'm going to double click on the tab here to have that class file open up larger. Extending mono behavior as we always do, and then I've got separate methods for showing some key features. So going down here, we're going to take a look at some functionality related to generics. So let's take a look at a common task that you need to do specific to Unity, which is getting an instance of a component. So if this code here is on the manager game object inside of our hierarchy, and we wanted to access a different component that's on that same game object, we would use this get component methodology. And if I type get component here, you can see a few options. I can get component. If I anticipate more than one result, I can get an array or list of the results. I can get component in children, and also a list and get components with an S in children. And the default syntax is here, or let's say a starting point for the syntax would be the first in line 109. And what you do there is you get a component and you pass in which type of component you want to reach for as you're looking. And if that component, sample component, exists anywhere on this game object, it will give you a reference to it. So let's take a look at the Unity project here. So main manager's game object is there, and don't actually have a reference to that. Sample 1, sample 2. Okay. So you can see here it says sample component 1 : and nothing is tracing out after the colon, right? I was a bit surprised there because we're looking for sample component, but it doesn't exist, right? So the way to complete this exercise is on the manager's game component, we would add and put sample component. Okay. So here's an example now of manager's game object, which contains two different components, and we're having the first component grab an instance of the second one. This is very common, fundamental Unity development where a game object has multiple scripts. Each of the scripts need to access each other. By script I mean component. I use those words interchangeably here. So I mean a mono behavior class, which an instance of it is a component here. So now that when I run the class file, we see that sample component 1 in the highlight returns a sample component, right? So the syntax here in the first one, I'm passing in the type, but this method, if I allow for autocomplete, it shows that it is returning a Unity engine.component. So in order to get it to play nice with the compiler, I need to type it as sample component. You can type like that, or you can type like that. Both of these say whatever get component returns, cast it as sample component. I prefer the as syntax, so I'm going to put that here. The alternative, which does take advantage of generics, the first one did not, is what we have in 113. So we're getting component, and then we use this funny syntax here of less than, greater than, and that is saying get component of this specific type, and that method can accept any class name, and it will return only a value if it corresponds to sample component. So line 109 and 113 are really doing the same thing, but the second instance is using a generic, the second example. Okay? So we'll understand a little bit more about this when we take a look at our generic class custom example. So let's take a look at, we're talking about doing shots here, right? Shots of drinks. So if we have a shot generic class and we want to measure the milliliters that have been drank, just as an excuse to have a property of something, we imagine that in one implementation we want to accept unsigned integers. We've had 1 milliliter, we've had 5 milliliters, right? But it's always going to be whole positive numbers as integers. Then a different use case entirely somewhere else in our project, we're going to need to do something similar, but we want to measure it more accurately. We want to measure in floats. So rather than have a class that can accept one and does rounding in other cases, or rather than have two completely different class, one that's shot generic class for ints, one that's shot generic class for uints, etc., and doing different declarations for each class, etc., you're able to make this class more open in how it operates, more generic, so to speak. So what we're able to say is, let's make a class that can operate only on uints, but in another case it operates only on floats, in another case it operates only on double, or whatever class we want to pass in there. Right, so let's look at the way that that's declared. Similar to all of our other declarations in 34, except here we use this curly bracket and capital T. Right? And that is syntax that means, okay, whenever someone declares this, they're going to pass in some type. That's the T stands for type. Then I can use that T throughout this entire page of code, anywhere I want that generic value to be acceptable. So here we've got public T milliliters drank. So instead of public float or public uint or public double, I just say public T. And now when the developer who's using this class instantiates it, they can say, yeah, I want to use uint or I want to use float. Right? Then down here, anytime you want to use, you just continue to use the T. And T here and T here means that needs to match whatever we've defined as T. So let's take a look at how the compiler can help us there. So if I use uint here, but I try and cast it as uint here, it will say cannot convert, from one class to another class. It really sees these as two different class definitions. So I correct that and say, okay, uint. Then down here I've got an update internal storage, and it's expecting this type to match whatever I've defined here. So let's try, if I change it to 42.2, which is a float value, and then I'm using project build assembly or build all just as a way to test a compilation here. It's without having to go back and play inside Unity. It's going to give me quick errors here, so I'm able to test out, and it says, okay, basically it says there's some problems here, but the problem is that it's expecting a uint and it's taking a float. Then in the second case where I've done declare to, same setup, except now it takes floats. Where up here it didn't accept a float, now it does. So you can begin to see the power of when you might use this. And if you're not used to generics, it may not be obvious. you'll be taking advantage of the key places where Unity offers it to you, but might not be using it in your own custom code yet. But there will be a time when you'll see. It's a very great time saving and gives you flexibility in your coding. Then let's say that while shot generic class allows you to put in anything for T, maybe you don't want it to accept exactly anything. You instead want to be able to pass in a custom class, and only a custom class. So let's look at shot generic class with a where. And we're really doing the same thing. We're updating the internal storage, which is an awkward name for what I mean is, setting the amount again, and then tracing at millimeters drank. So it operates similar to the last one we looked at, but it's a new declaration altogether. If I go to that declaration, it looks similar here, but then it says where T:(I amount. And you're able to specify any interface there, I think. Let me see what else it says. It must be any class or interface. Okay, so I chose to declare an interface. So now whenever I'm using this class, it's going to make sure that whatever I'm passing in for T is something that implements the interface I amount. So here we're getting even more control over the situation. Same basic methods that are going in there, but I'm passing in the big shot amount, and that is a class that implements what we want to implement. So that's cool. So that's generics. Then let's take a look at the delegates example. Wait, I might have an error here. Make sure that gets cleaned up. Nope, we're good. All right, so in the delegates, let's give that a run. So here we've got an example of delegates, func, predicate, action. We do have overloaded method in here as well. So let's take a look at that. So I'm doing some work along with a custom class called cocktail. And let's take a look at that cocktail first. Go into the declaration. So this cocktail is meant to be a mojito or a Bloody Mary or any kind of drink cocktail, so to speak. I'm really not taking advantage of that metaphor too much. So what we do to use a delegate is we need to define what the delegate is. We need to create an instance of that type delegate. Then Then we call it as if it's a method, right? But uninitialized isn't a method per se. While it looks like I'm just simply calling a method here, I'm actually calling the uninitialized delegate uninitialized. So the paradigm that I'm explaining here is if you wanted to have a class that has an initialized method, as we do, and then I wanted to be able to broadcast out a message or an event to the rest of the world that cares about it, that okay, I'm now initialized, right? Something that in other languages you might use something like an event dispatcher paradigm. That doesn't exist direct right off the bat. Instead, you get delegates, and delegates are the preferred way that Unity communicates out these types of notifications, to use a generic term, or events, to use a generic term, meaning something has happened in the code and you want to make other scopes aware that that has happened. So that's when I'll say the word notification, right? So how do we listen for that from outside? Let me open up our example again, so we're focused here. Okay. So I create a cocktail, and I trace out that cocktail. I'm just showing some unrelated string formatting issue there. Then under delegates, use this funny syntax that you might be used to seeing from like uint n equals 10, n plus equals 5. So in this case, it's saying take the value of n and make that equal to n plus 5. Right? To save a little space, you write plus equals. So that is a wholly different use of the operator plus equals. This is a mathematical instance in 105 and 106. So don't let that confuse you with what this is. This is a specific operator that means anytime the delegate oninitialized is fired or broadcasted or the message is sent, whatever language you want to use for that, I want to listen to that with this handler. So this is the delegate handler. If I jump down to where that is declared, this is inside the core class here and inside events. And I note, okay, this is a loose term. I don't mean events in quotes because that's something else that we'll talk about in a moment. Just anytime I'm handling some messaging, right, I'm calling that in this down in this section. So I'm able to hear back anytime I want. Now the minus equals here says don't notify me anymore. Maybe I only want to hear about this once and I don't care about it again. Right? So you have the flexibility to observe when you want with plus equals and stop observing with minus equals. Okay? So let's see how that works. So as soon as we run this, then I immediately call initialize. And that's just my way to have oninitialize call right immediately. And that is going to call this code here, and that's going to have oninitialized and the message trace out. So we see over here that all that together makes oninitialized happen. So what's a scenario where you might want to use custom delegates like this? Well, perhaps you have a class that's holding the score for your game, and every time that score changes, you want to pass a, the score just changed, and then any classes that want to listen to the score just changed. I'll make an example here. Let's say you've got your game class, and I have on score changed equals tell me when score changed, like that. So you might have a game that has a on score change delegate, and then to handle that delegate, you have a local method that you want to tell me when the score changes. So maybe the GUI text listens to the main game code. For every time the score changes, I'll listen and I'll update the score. Right? There's countless ways you'd want to use this type of messaging, and it's very friendly. Something else that's really nice is that it's a one-to-many operation. So if I have different methods on the same class, same scope, or various other ones, there can be 3 different methods that listen. There can be 10 different ones. There's as many as you want. So it's not like in another language where you would set an anonymous function or something like that, which is a one-to-one messaging. This is one-to-many. So on score change can broadcast or send a message to as many as you want, which is very nice. All right. Now the example I just gave of anonymous methods, right? Different way to handle the same issue. Let's say you had a long process and you say, okay, do the long process, and then when you're done, call this code. Right? In another language, you might be used to this being like function like that, where you're passing in an anonymous function. Or you might be used to something like this, bar test equals that. So a 2-step process. Define a local function. The syntax might be different. I'm just making this up as I'm going here. And then you pass in that. And then inside long process, it would call the test method. Right? You could do something similar to that, but there's some more robust language-specific features here for this, which is really nice. So the first one is you can use what's called Lambda. And Lambda syntax looks like that. And it's shorthand for this function that with that. And if you want a parameter like uint score, then in the body you can use score however you want. The equivalent of that here, same exact thing, it's deceptive how short it is you have uint score, and then somewhere in here you would just say score. So this is just like function. Right? The idea is that it's very short, it's very terse, so that it doesn't take up much space, and you're able to pass in anonymous single-use functions. Right? Another way I'm showing here, or you could just pass in a whole method declaration just here. And so this is an advanced topic, and I'm going quite fast, so this is targeted to people who understand already some of these issues architecturally that you need to do, messaging, etc. So this is what's called Lambda, and this is passing in a reference to a method. Then a second thing you can do is you can declare a function inline. This is similar to function ABC, int a, and then using a. It's not helping me the way that it's auto-correcting here. But it's something like that. So it's func, and then inside these brackets we're saying we want to take int, and a float. And that means here's the name of it, take an int and an int in, use the int and the int, and return a float. So this last one is always the return type. So this would be like function int a, int b, and then return float of a plus b divided by 2. So it would be something like that. Right? My syntax might not be perfect here, so I'm just going quick. Right? And then you can instantly use that method 1 line later, 10 lines later. And the idea with all these 4 steps, 1, 2, 3, and 4, is it's saving you from needing to dedicate the space and the scope for a fully declared method that maybe you're only going to use one time, or you want to actually protect that it's only called within the scope of line 123, 124, etc. So you're able to control the scope. Right? So there's func. So func has a return value. Then predicate, same basic idea, except predicate, it always returns a Boolean. Right? You might say, all right, why don't I just use a func and always return Boolean here? You can do that, but in cases where you architecturally only want to return Boolean, such as sorting routines, you wouldn't pass in a predicate. It's more common than you might think that you want to be able to pass in a method that returns only a Boolean. So that's why predicate exists. And that's used in the native C# libraries, and I think in Unity in some places, including sort. Can't remember where, but maybe in the list class or something. Then 4, there's something called the action, which action, because it's action oriented, it does something but doesn't necessarily return anything. Right? So here we're saying I'm going to declare something like a function that is going to take in 2 strings, and then it's just going to do something. And here's the doing something is debug log. Right? And so then that's it in use. Now lastly, let's just talk about overloading. Overloading is a very cool feature of C#. It doesn't exist in some other languages. And what you are able to do is, instead of having one method that takes in no parameters, takes in a uint, and takes in a string, which is possible. You could make something take in any parameter or any list of parameters and then check which ones came in and do wildly different things. Overloading is you declare the same method multiple times. Here you see overloaded method, and here you see overloaded method again. And the only difference, you see the naming is the same, is that we just redeclare it, but one with empty, one with one parameter. If I wanted to have it work with a string, I would just do this. You're just redeclaring it, and that just lets you do completely separate logic based on the combination of what's coming in. And countless Unity methods work this way. And I'll give you an example of that. let's say get component, which I talked about in a recent example. Here, if I start get component and do open, the tooltip here, it says 1 of 3, which I can then use the arrow keys up and down, and it's showing me I can either pass in nothing, I can pass in type, or I can pass in string. And sometimes it's, let me see, another example, physics, Raycast. Okay, here's one with 12. I just remembered this off the top of my mind, but there's countless examples. And they go through a lot of different combinations. Sometimes it's just the order. Maybe you want to pass in ABC, then BAC, then CAB for different reasons. Different ones can be optional parameters. It just lets you code more specific combinations of the parameters that you want to accept. And that's it. Next, let's look at threads. So when we run the example here, we see that this flying cube is spinning and it is jittering back into space. And that is just a visual cue that I'm using on cube here. Slide this down. On cube I have a move right component and a rotate right component. So let's look at each of those. Move right. I've got some examples, some comments here about the issue that you can take a look at. But all I'm doing is I'm invoking repeating, which is one of Unity's built-in ways to repeat code. And also I'm using a start coroutine. Coroutine is another way to have code repeat. I talk a little bit about here in the comments why you'd want to do one or the other. And then in update, which happens every frame, I'm doing a translation as well. So the idea is that we've got code running every frame, running sometimes, and running sometimes as well at slightly different speeds. Then inside the other class, which was cubeRotate, I'm doing something similar. I'm doing something in the update only. Okay, so here I'm just doing update. And if you look at the output, if you enable some of these traces, look at the output and just study the way that that box is moving, you'll see that all of this code is executing. This update, this do repeating, and this coroutine, and they're all separate threads where if one was crunching too many numbers, it would actually allow the other ones would still be being called. They're actually called separately. Right? This is just an example of the syntax. It doesn't really explain to you why you might want to use these, but just know that these are some of the options you have for threads. Then let's look at the extension methods. So extension methods are very cool. When I go ahead and run this, the only trace here is find distance to origin, and that is just measuring the distance between some point in space and the origin. And I think that point in space is, let's look at the source code here. So I am creating a new game object. I'm moving it somewhere in the space. And then I'm just calling find distance to origin, which just says, okay, if I'm sitting here, what's my distance to the origin? And origin is the point 0, 0, 0. So it just does some simple math. But the whole thing that we're showing here, the magic, as I say in 85, is that find distance to origin is not native. So while we're using a native object instance called game object here, this is not declared on that structure. It's not offered by Unity. We've sprinkled in, we've peppered in, we've added this functionality on top of it. So how would we do something like that? Well, if we look at the reference, if we look at the declaration, I've got a class here in the tab Game Object Extension with a very specific syntax. So Game Object already exists, but I name this static class Game Object Extensions. And then I use this quite awkward syntax with a this, etc. And I'm able to allow all existing game object instances without ever subclassing them or creating my own custom super game object class, as I've done something like that in other programming languages. This enables you to add one or more custom methods, other functionality onto existing objects. It's very powerful. So it's an example of it here. You might want to do just that. Then let's look at operator overloading. So here we've got lots of stuff tracing out. We're talking about bar tabs, the money that you got to pay at the end of a day at the bar. And then we will look at the source code example for that. We have a custom bar tab class. I've got one for the son, one for the daughter, and then here we say that the mom, her bar tab is, we add the son's bar tab. And this is the mathematical, u at n equals 10, n plus equals 5. It's doing the mathematical plus equals. It's not doing the plus equals operator that we were just exploring with delegates. This is the mathematical one. So I'm saying take the mother's bar tab and add in the son's bar tab and add in the daughter's bar tab. Right? But the magic here, as I say in 108, is that the plus equals, which typically just says 5 plus 10 is 15, I'm able to customize exactly what code happens there. So this is really powerful. These are all the ones we're able to override. So overloading an operator, let's take a look at the instance. Go into the definition. So you declare a method, it's static, and you use this special syntax, operator plus, operator minus, operator equals, doesn't equal, less than, greater than, all those combinations that are compatible. And you take in the types you need and you return the value that you want. So if there's a class where you need to do something other than the default 5 plus 10 equals 15, maybe you want to make 5 plus 10 equal 40, or any other operation that you want to do inside there. You can do that with operator overloading. So that's that. Encourage you to dig into that source code. Then here's what are called attributes. So let me run that. So here you see obsolete, obsolete 2, and custom attribute. Attributes are those things that we see in square brackets. So I explain what all of these are and give quite a few examples. The only one I'm going to go into depth about, just to show you the power of it, is, let's say I have demo of attribute obsolete. So look at this comment. It says that method is obsolete, which means something that is no longer in use, right? No longer useful. In the comment it says use not obsolete instead. So it even gives me a little correction. So this is great if you're maintaining a code base and everyone is loving this method everyone's loving the method in 188. It's working great for everyone. Then one day you decide to change it, but you realize a lot of the developers are already using this method. So what you do is you present an alternative down here of, where is it? Oh, I don't have the not obsolete. But anyway, you'd create a new method and then you'd add in this comment. And you're just saying, tell the compiler to give a warning anytime someone uses it, and then throw them this message. So it's just a way that you would migrate from an old code to a new code. Right? The second parameter here is a Boolean for, is it a warning, inline 187, or does it actually throw an error? So depending on the severity of how you need that migration to happen, slowly or quickly, you can have that power to either throw an error, or in this case, yeah, so you see in 163 shows the error there. All right, that's that. Then if you want a custom attribute, you can do that too. So let me look at that here. Here, so this is an attribute I created myself, and I'm able programmatically to get at this value, that value, this value, anything you want. Right? So you can explore this example to see how to do your own custom attributes. That's really powerful. Then preprocessor directives is the last thing we'll take a look at here. Preprocessor directives, you can see over here we've got conditional compilation, native conditional compilation, a couple different key areas. Let's look at the source for what we're doing there. Preprocessor directives, they look like this. They start with a pound sign. If you are using monodevelop and you use pound, it will give you quite a few options. Some are related only to Unity script, but the ones that I show here are very related to using C#. So if I call this, I'm defining please do this, and then later I can check if that's defined or not. So what this enables you to do is kind of use this like a Boolean. That's kind of like false, that's kind of like true. And if we go down here, if that was true and declared at the top on line 0 or 1, then it would run line 74. If I comment that out, it will not run line 74. Right? So it's very useful. It's a way to do what's called conditional compilation. Some of these tags are defined for you. Oh, sorry. Some of these tags are defined for you by Unity. Some of these, maybe you'd call them a flag. One of them is in the case of the platform. Unity, when it runs the code for you, anytime you hit the play button, it's going to have some of these set and some of these not set. Then you can do code specific to a given platform. So maybe you're checking for the accelerometer of a tilting device in your hands in the case of mobile, and in the case of desktop you just ignore that code altogether. And what is not executed here just doesn't even reach the compiler. So it's as if you've deleted it, saved, and run the code. Right? So it doesn't even get executed at all. It's like treated like a comment, maybe you can think of it. Then there's some pragma. These are some of the examples. You'll see that quite a bit in code samples around the internet, but it's related to JavaScript and is about how specifically JavaScript compiler, Unity script compiler tries to look at your code. Then if you wanted to have some scenes get executed depending on what device you're on, you can look at this great post here. So I didn't build an example out of it, but that's it. So that's the example there. We've taken a look at generics, delegates, threads, extension methods, operator overloading, attributes, and preprocessor directives. So some of it I went blazing fast through, but I encourage you to take a look at the code there and learn from it. Thanks a lot.